Hello everyone. Today we are going to see about transformers. Introduction of transformer. A transformer is a static electric device, meaning it has no moving or rotating parts. Its job is to transfer electrical energy from one AC circuit to another AC circuit with a change in voltage and current levels, but without changing the frequency. In power plants, electrical energy is generated and transmitted at very high voltages. Using high voltage reduces the current and for a given power, which in turn reduces 1 squared or I square R losses in transmission lines. But at the consumer end, such as homes and industries, we cannot use these very high voltages directly. So we must reduce the voltage to save and usable levels, and this is done using transformer. When transformer reduces the voltage from higher level to a lower level is called step-up transformer. When it is increase the voltage from lower level to higher level is called step-up transformer. When the transformer changes voltage, it also changes current in the opposite way. Stepping down voltage, step up current, and stepping up voltage, step down current. Ideally keeping the power almost the same apart from losses. Types of transformer. Based on the supply system, there are mainly two types. One is a single phase transformer, three phase transformer. Single-phase transformers are used for single-phase loads such as domestic supply and very small equipment. Three-phase transformers are used in generation, transmission, and distribution networks where three-phase power is standard. Even though their application differ, the principles of operation is the same for both single-phase and three-phase transformer. Principles of operation. Let us now understand the basic principle operation. A single-phase transformer has two highly inductive coils called winding wound on a common iron or steel core. The windings connected to the AC supply is called primary winding, and the winding connected to the load is called secondary winding. When the primary winding is connected to a single-phase AC supply, an alternating current flows through the primary. This AC primary current produces an alternating magnetic flux in the core. Most of the changing flux links with the secondary windings through the core because the two windings share the same magnetic path. The varying flux induce a voltage in the secondary windings according to Faraday's law of electromagnetic induction. This induced voltage in the secondary is produced mutual induction between primary and secondary. Therefore, EMF in the secondary is called mutually induced EMF. Why transformer cannot run on DC? A common conceptual question is, can transformer work on DC? The answer is no. With the DC supply, the primary current is essentially constant, so the flux in the core is also constant and does not alternate. When there is no change in flux, there is no change in flux linkage in the secondary. According to Faraday's law, if the flux is not changing, the induced EMF in the secondary is zero, so the transformer action disappears. Practically, if we connect the transformer to DC, the primary winding behaves almost like a low resistance coil, causes very high current and possible overheating or damage the core and winding. Construction features. Now let us briefly look at the construction. Basically, a transformer consists of two inductive windings and a laminated steel core. The coils are properly insulated from each other and from the core to avoid short circuit. The coil in practical transformer, especially larger ones, there is a metal container called the tank for the winding and core assembly, bushings and bringing out the terminal and an oil conservator for cooling and insulation. Laminated steel core. In all type of transformer, the core is made by stacking thin laminated sheet of steel with a minimum air gap to create the continuous magnetic path. The steel usually has high silicon content and may be heat treated to provide high permeability and low hysteresis losses. The lamination are used to reduce eddy current loss. The sheet also are commonly cut into E shape, I shape, and L shapes and assembled so that the joints are staggered. One layer has joints on the front face, the next on the back face, which reduces magnetic reluctance at the joints. Different cross-sectional of core limbs are used to optimize performance and reduce size as shown in typical transformer limb diagrams. The shape of cross-sectional help in better space utilization for winding and lower losses. In larger transformer, the entire core and winding assembly is immersed in insulating oil inside the steel tank. The oil acts both as an electrical insulator and as a cooler, carrying away heat from winding and the core and transferring to the tank from the where it is dissipated to the surrounding air.